In this video, we'll talk about finding probabilities for a normal distribution using a computational device. So if we're asked a question like, heights of adult men in the US are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. If one adult man is randomly selected, what is the probability that he is less than 6 feet tall or less than 72 inches? To approach this problem using like a calculator or an online tool, in most cases, computational devices allow us to input the mean and standard deviation. So we don't necessarily need to convert the data value to a z-score in the standard normal distribution. But I would like you to know about the connection between normal distributions and standard normal distributions as described in the previous video. And if you're curious about how you might use this approach with z-scores, you can also check out the video Finding Probabilities for a Normal Distribution with a Table. But if we're using a computational device, most of them are similar. Here's the one I'm using at this website. If you Google normal distribution calculator, you'll find this website as well as other similar ones. And it looks like this. So you put in your mean, mu, your standard deviation, sigma. Initially 0 and 1 are the defaults, but you can change those. And then you put in your data value that you're interested in. This will really be x instead of z if we're talking about a normal distribution with a different mean and a different standard deviation, something that's not the standard normal distribution. So you'll enter those three values and you will get output of that second value, the probability that x or z is less than a particular value. And this and most online calculators always give the probability that we're less than a particular value, either x on a normal distribution with mu, mean mu and standard deviation sigma, or less than a value z if we're talking about the standard normal. And remember that the standard normal distribution has a mean of 0 and a standard deviation of 1. All right, so if we're looking at our example, the heights of adult men in the US are normally distributed with a mean of 69 inches and a standard deviation of 2.8 inches. If one adult man is randomly selected, what is the probability that he is less than 6 feet tall or less than 72 inches? Then this is the normal distribution that we're looking at. Mean of 69 inches, there's our mean, and standard deviation of 2.8 inches. So each of those tick marks is one standard deviation above the previous. And we're looking for the probability that he is less than 72 inches or less than 6 feet tall. So here is 72 inches or 6 feet tall, and we're looking for the probability that this person falls within this region. So it's going to correspond to this shaded probability right here. So in the online calculator, we need to input the data value. X is 72, the mean, mu, 69 inches, and the standard deviation, sigma, 2.8. And we enter those three values. After you enter it, initially it's going to say standard z-score, but after you enter it, once it realizes that the mean isn't 0 and the standard deviation isn't 1, it's going to change this to a normal random variable x after you've entered it in this particular calculator. And it gives you that the probability that x is less than 72 is 0.858. And so that's all you need to do. The probability that x is less than 72 is 0.858. So that is our probability. What if we wanted to find instead the probability that one randomly selected adult male has a height greater than 72 inches, more than 6 feet tall? So this is our x value, and we're looking for the probability now that we're in this region. So remember that that blue shaded region plus the green shaded region over here, the total probability under the curve is 1. So total probability under curve is always 1 for any continuous distribution. So the probability that x is more than 72 inches is equal to 1 minus the probability that x is less than or equal to 72 inches. And that's what we found above. 1 minus the probability we found above was 0.858. 0.858. And when we subtract 0.858 from 1, we'll get 0.142 is this probability that we're looking for. This probability right here on the right, the blue shaded region. And anytime we're doing a greater than, we're going to do less than and subtract that value from 1 to find the value for greater than, the probability that x is greater than a particular value. All right, what if we want the probability that this randomly selected adult man is between 65 and 75 inches tall? Then we're going to find the probability for both 65 and 70. So we input 65 as our x value, we input 69 as our mean, we input 2.8 as our standard deviation. So we do this twice. And then this is our output. So this is initially blank, but the program gives us this as our output. So the probability that, what we now see is that the probability that the x value, that the height is less than 65 inches, something around here, is this 0.077. 0.077 is this probability down here. And the other probability that x is less than 70 inches, so that's about here. The probability that x is less than 70 inches is all that purple shaded region. That probability is 0.640. And when we want to find just the region in the middle, that means we want to take the purple minus the blue. So this is the probability that 65 is less than x, which is less than 70, is equal to the probability that x is less than 70 minus the probability that x is less than 65. And so that's equal to the first probability that the probability for 70 we calculated was 0.640 minus the probability that x is less than 65 was 0.077. And so when we calculate that out, we'll get 0.57 is our probability that we fall in between those two values, between 65 inches and 70 inches. All right, here are a few for you to try. IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. If we randomly select an individual, what is the probability that they have an IQ score above 90, that they have an IQ score between 80 and 125, and that they have an IQ score below 125? And for each of these problems, I'd recommend to shade the corresponding probability on a normal distribution. All right, for an IQ score above 90, so 90 is about here, and we're looking for the probability of being in this region, the probability that x is greater than 90. So for the probability that x is greater than 90, we are going to plug in some values into our online calculator. X, the data value is 90, the mean is 100, the standard deviation is 15. We're just plugging in those values and finding a probability. The probability that we find, though, is not going to be that one that we're initially seeking. The probability that it's going to output us is the probability shaded in green, the probability that x is less than 90. So what we want is 1 minus the probability that x is less than 90. Again, that's what the most computational tools will give you as output. And so that's 1 minus. When you plug those values in, you'll get 0.252. And when you subtract, you'll get 0.748. And that is the probability that we're looking for, the probability that x is greater than 90, that this randomly selected individual has an IQ score greater than 90. And I think it's useful to do these shaded pictures, because if you forgot a step and you just did 0.252 and you say, well, wait, this shaded region I want is definitely larger than a half, then you know that something was wrong with your 0.252, which again corresponds to the green region. So that green region here is 0.252 is that probability, whereas our purple is the 0.748. Okay, an IQ score between 80 and 125. So here we have to find each of these probabilities. So the probability for 80, and so that would correspond to everything below 80, as well as the probability for 125, and that would give us the whole region, including that green shaded area. And then if we subtract those two areas, we get the probability that we want, the shaded region in black between 80 and 125. So the probability that 80 is less than x, which is less than 125, that this randomly selected individual has an IQ score between those two values, is equal to the probability that x is less than 125 minus the probability that x is less than 80, the purple shaded area minus the green shaded area. And so that's equal to, now we're just going to plug these in. So we are plugging in to our computational device at this point. We are plugging in x equals either 80 or 125. So we're doing this as two separate checks. The mean is still 100, the standard deviation is still 15, so we're plugging those values in. We're doing this, clicking this twice. And so when we do for 125, we get 0.952 minus, when we do it for 80, we get 0.091. So try this yourself as well to make sure you are putting in all the right stuff. And when you subtract, you will get 0.861. So that is the probability of this shaded region we're interested in between 80 and 125. All right, for an IQ score below 125, we've actually done this already essentially. So 125 for less than, this is what the computational device will already give us. So we don't need to do anything extra. We just need to plug in x equals 125. The mean is 100. The standard deviation is 15. And then the probability that x is less than 125 is just going to be what this program or whatever spits out. And we already calculated that. That was 0.952. So that's that blue shaded region right there.